Now we'll see how to design primers for PCR and also for real-time PCR. In case of real-time PCR, we are also designing a probe. So how to design primers? So for that, we need to go to NCBI's nucleotide core, and this is the hyperlink for that. And once you're in this website, give a search. And today I want to design primers and probes for human CD2 gene. So what I will do is I'll type in Homo sapiens CD2 molecule mRNA, and I will give a search. So once you give a search, actually you have an option to select if you are trying to design for animals or if you want mRNA. So these are pre-selected because that's what I was designing before. So I select animals and then I select mRNA. So that is what I want. And so once I'm here, I will choose the transcript variant 2 because this is the accession number I was seeing in publication. So I know this is what I want. But many times you will see that Homo sapiens, the gene name that you want, and straight away there is mRNA, there are no transcript variants. Try to ignore, because you get almost 56 searches, try to ignore the ones with complete CDs, which you will see many, and you will also see many other related or unrelated genes to CD2. So for now, we'll go to transcript variant 2. I'll click that. So at this time, you want to make a note of what the accession number is, what is the locus, NM_001767, and you want to note down that it is 1582 base pairs and it's an mRNA and it is linear. And pretty much just copy paste this information into your Word document or an Excel, whichever you are following. And the definition, the whole name, sometimes you might want to go and refer back what kind of variant it is. So this is also information that you would want to note it down. So once you are here, it gives lots of publications and those things that are related to this gene. For now, we are not interested in that. So we'll go down. Once you go down, so you will see exons. So this is an important information for you to design. So you will see here that there are 4 exons, 125 to 445 region of the bases, 446 to 676, 677 to 799, 800 to 1565. So these are the exons. So you want to make a note of those exons. What are those exons? And you have to target at certain exon for your design, because you want to design primers or probes at the junctions of exons. So you have to target one of those start points of an exon. So here is an mRNA sequence. You will see it. So these are at a set of 60 in each line here. So 1 to 60, 61 to 120, and so on. So you have the whole mRNA sequence here. So what you do is you copy paste this information sequence, and you will also save that information on your Word document, and also the exon numbers, the regions, you want to note it down for your future reference. So once you do that, what you do is you have to go into Primer 3 software. This is a free software also. It's available online, and it's a very famous software, quite popular. There are many other options to design your primer. So this is one of the most used software. So I usually design it here. There are also some publications which show an advancement of this software, and what are those advancements. So what you do here is you go here and paste your mRNA sequence, and once you paste the mRNA sequence, you want to pull down this menu and say that this is human, and then you want to select left primer and right primer, which are already selected, but you should also select a hybridization probe. This is an internal oligo which is required for real-time PCR. And once you are here, you need to select an overlap junction. So I had noted it down that in case of CD2, my last exon starts at 800, so I want to choose that as an overlap junction. So I will say 800. So that is where my primers, one of the primers will be designed. And once I do that, I go further down, and then here are general primer picking conditions. So these are by default given. So what I do is I change this to 22, minimum size and maximum size. So my optimal size would be around 20 bases. And I say 58 degrees to 62 degrees, and my optimum is 60 degrees for TM, the melting temperature. And I don't touch this, and I want to select 40 to 60% the G and C percentage. So my optimum should be 50. So this is something that I select for primers. So then I go further down and I will see the same information for my oligo. So I say, because I'm going to design my order my probes which would be for MGB, non-fluorescent quencher. So for me, a 20 bases is good enough. And similarly, 58 to 62 of TM, and then 40 to 60 GC percentage I select, and that is all. I don't do much. And most of the conditions that are required for the primers and probes are already taken care by the software. So then I go down and I say pick primers. So once I do it, it will select the primers for me. As you can see, the start of this primer is 789. It is going for 22 bases of length. So it covers my junction region, exon to exon junction region, which I said should be around 800. So that is covered. So so this is the information I get. And so this is my first primer, the left primer, and this is my right primer, and this is the probe. So once we have this information, if you go down, it will show it which region it has designed primers and probes for you. And it also gives additional oligos, additional primers and probes, different sequences around that junction. So you can note down, and if you want to order more than one primer probe sets, you can order and check and see which one works well for you. So for now, let's just choose this information. What I do at this time is we need to be sure that our primers amplify the region that we are interested in. It doesn't overlap, or there are no other genes which are sharing same sequences that our primers would go and amplify. So for that, we need to do a blast search. So I select this region, I go into blast.ncbi. So this hyperlink, you can check it out. And I click nucleotide blast. And once I'm here, I paste my sequence, and then I go down to the database and I make sure that it is human genomic plus transcript. That is the database. I think by default it selects the mouse, so you need to change it to this. And once I do that and I click blast, so it takes some time, anywhere from 10 seconds to minute, 2 minutes, or even longer sometimes. So to save time, I have already done that. So this is the result that you get after you do it, and you see that there are few sequences that are matching 100% to this primer in human genome. So if you go down and see, the max score is 44, and it is 100% matching with CD2 mRNA. So that is what is of interest to you, because you might find many other predicted regions and those things which you shouldn't worry at this time. So this is a sequence which comes up first. So you are pretty sure that your primer is amplifying the region that you are really interested in. And similarly, you will check, do the same search with your other primer and probe, and make sure that it is amplifying CD2 mRNA or your gene of interest. So once that is done, you are pretty much secured, and you can place order for primers and probes. In relation to probe, you choose your own fluorescent molecule and then the quencher, the detector and quencher. So FAM is the detector of my interest, and NGB is the quencher of my interest, which is a non-fluorescent one too. And probe is an expensive aspect of your real-time PCR, because the primers you can buy for $10-20, but probe is anywhere from 100 to 150 or even more. So one easier approach is to order the primers, the left and right primers, more than one pair from your Primer 3 software searches, and do a cybergreen real-time PCR assay and check if your primers are amplifying, which set of your primers are amplifying better. And out of that you can choose the right primer set and then order an appropriate probe that you have already designed. And then you can order that with the FAM and the TAMRA or FAM and NGB combination and use it. So that is the way to design your primers and probes online. So thank you very much.